All right, very good. Thank you, Gianluca, and thank you to the whole SQL Start organization team. It's a pleasure to me to be here today again in this great event, presenting about SQL Server and some of the topics that are around. Right? Today, we're going to be discussing a little bit about the different high availability and disaster recovery options that we have in SQL Server and Azure SQL. So in the next hour, we're going to try to understand few of the terminology that goes around this topic. We're going to see which are the things that we should pay attention in order to have this covered for our environment. A little bit about myself. My name is Javier Villegas. I am from Buenos Aires, Argentina, and I work at Mediterranean Shipping Company as IT Director in the DBA and BI services areas. I've been involved with SQL Server for more than 25 years. I am Microsoft MVP in the data platform category since 2016, and also Microsoft certified trainer. I'm also a member of the Azure Data Community Advisory Council. I'm also one of the organizers of our local community, SQL Argentina, and where we have our meetups and our, meetings virtual, now hopefully soon in person. So feel free to join us. Of course, this is a Spanish-speaking community, but if you would like to, you are more than welcome. On the left side of the screen, I have my contact information. So if you have any question regarding to this presentation, feel free to reach me at any time. All right, so this is kind of a marketing slide, which I like to present because graphically speaking, represent quite well what Azure SQL is, right? A few years ago, Microsoft came with this new concept of Azure SQL, which in fact is a grouping of different services and products as we know them. So we will try to cover them quickly. First of all, one of the Azure SQL members is Azure SQL Virtual Machines, right? These are virtual machines running SQL Server, the same version and edition that we've been using forever in our laptops, in our data centers, in our production dev test environment. So this is exactly the same SQL Server. The good thing is that, first of all, it's in Azure, and there are several benefits of being in Azure. But the good thing is that when we go to deploy one of these virtual machines, it's quite easy because we have the Azure Marketplace in where we can choose between a long list of combination of operating systems, SQL Server versions, and edition. Right? You know that since SQL Server 2017, we have the possibility of running SQL Server in Linux environment like Ubuntu, SUSE, or Red Hat. Right? So we can choose any combination, Enterprise Edition, Developer Edition, Standard Edition, and we can go to early versions like, for example, SQL Server 2008 R2 running on Windows Server 2008 R2, right? Hopefully nobody needs this, but well, we have the possibility, and Microsoft give us support if we want to do this, right? One of the things to mention regarding to this virtual machine is that same as we do today, in our own data centers, we have to take care about all the infrastructure that is around that SQL Server environment. That means authentication with Active Directory, backups, high availability and disaster recovery, setting up, the clusters, the availability groups, etc. Some of the things that we will be covering in a few minutes today, right? So we have to take care of also the updates, the patchings, right? If there is a patch that is released for either the operating system or the SQL environment, we have to plan the maintenance and do it, right? So this is a bucket that is called infrastructure as a service, right? One of the things that I like the most of this virtual machine is that we have several features, several good things just out of the box. First of all, when we create one of these virtual machines, we have the possibility of getting a bunch of the best practices that Microsoft has released over the year for SQL Server, right, already there in our deployment. For example, the possibility of just having the data files in a specific drive, the log files in another one, setting the location for the TempDB with multiple files, setting up the max degree of parallelism, etc., etc., etc. Many things. So we have it in the process of deploying one of these VM at the beginning, right? This is not something that we have to do as a post-installation or post-deployment step. We have it there immediately. And because of being in Azure and being a virtual machine, Microsoft also provides a certain level of high availability for our VMs, right? We're gonna, as I said, we're gonna go deeper in presentation. Then in the middle of the screen, we have two services, right? One is Azure SQL Virtual Machine and Azure SQL Database, right? This is entering in the bucket called Platform as a Service, in where Microsoft offered to us the possibility of just connecting to this SQL Server endpoint, right? And deploy our databases, our applications, etc., without us taking care of the infrastructure behind the scenes, right? So we don't know anything about the operating system, the disk, or anything that is behind this, because we just deploy the services. And why we have two, Managed Instance and Azure SQL Database? Well, each of them has its own, let's say, use case. Managed Instance is more similar to what we know in SQL Server, and Azure SQL Database is a little bit more targeted to modern cloud-native applications, right? So that is in few lines the meaning of each of them. But also Microsoft provides us out of the box certain level of high availability, and we're going to see how we can enhance it even more, right? And the fourth component of the Azure SQL family is Azure SQL Edge. We won't be covering it too much during the presentation, but just quickly is the possibility of running SQL Server in a device like this, which is a Raspberry Pi, right? So it's an ARM-based device. So we can have SQL Server in here, in where, of course, we won't run our critical workload in here, but for certain scenarios that are pointing to edge, like, for example, collecting, storing, and processing information coming from different sensors coming from the field, is a really great option, right? So that is SQL Server, that is Azure SQL Edge, right? So this is the concept of Azure SQL. If we go deeper, right, we see that today we have the possibility of running SQL Server everywhere, right? We can go from an environment that is edge to, a completely managed service, even, on the platform that we prefer, Windows, Linux, also containers. The good thing is that there are most important thing is that we deploy once, right? We write our code once and we can deploy it everywhere. It's not that we have to rewrite our code depending on the destination that we're going to be choosing, right? So we deploy once, and then we develop our application once, and doesn't matter which is the destination that we need for that particular development, right? If it is edge, if it is cloud, if it is hybrid, we can do it real quick. So this is a concept of all the Azure SQL components, right? So if we go a little bit deeper to see how we can, let's say, have high availability for all the systems, let's start with, you know, a couple of points that I would like to cover. First of all, nowadays definitely is not that complex than how it used to be in the past when we started the conversation with our managers about high availability and disaster recovery, right? I remember several years ago starting a conversation with my manager saying, hey, I may need an additional set of hardware and also to hire another data center in a remote location just to provide additional high availability and have the possibility of having disaster recovery for our environment, right? The solutions were and actually are a little bit costly, right? So the main question was, are we gonna get better performance? For example, if we invest all this money for all these components, and definitely the answer was no, we won't have a better performance. And so why are we gonna have these other servers just in standby mode, just waiting for something and without producing anything, right? And you know, the answer for that then is actually the same that it is today. We're going to have that in some sort of standby mode, just waiting to see if something happened in the main environment. So if something goes wrong, in as quickly as possible, we can have business continuity. Doesn't matter if, you know, our server, our virtual machine, or our service, or even the whole Azure region has a main problem, right? So those conversations are kind of, you know, well understood, right? So now everybody knows that maybe just having our system down for several hours and not being able to provide a service to our internal or external customers several times is even more costly than having these services or servers in standby mode to accomplish HADR, right? So this conversation, as I said, are kind of over. So now when we talk about the meaning of high availability and disaster recovery, is something that, well, everybody understands that is really necessary to have this in place, right? So the concept of high availability is basically that our system is being able to operate continuously, even if there is a problem, right? So any kind of problem, we should be able to move on and continue serving our, in this case, SQL Server databases, right? So doesn't matter if there is a problem with the hardware, a problem with the networking, or anything, we should be able to continue operating. And you know, what is important when we talk about high availability and disaster recovery is, you know, when we are designing our solution, again, in this case, SQL Server base, we should have HADR in mind from day one, right? When we design the infrastructure, the necessary infrastructure for our environment, it's important to consider all these points from the beginning, from the very beginning, right? Because it's way more easier to do it this way than, eventually the other situation, which is having an environment which is absolutely not possible to do high availability and disaster recovery. For example, a single server, right? With no redundant component, that if something crashed, we lost everything. Than, just having the whole HA solution created and up and running since the beginning. So what do we need to do here? Well, first of all, identify all the possible single point of failure. What does it mean? So we know that we have our system, our server, right? And my server has hard drives, right? Even if there are, solid state drive, there could be failures. Probably these failures are the most common ones that we can see. So we should have a system capable of stripping the information into multiple drives, right? So if something happened to one of these drives, the system continue operating with no problem. So we just get an alarm, we just take that disk offline and we put a new one, right, with no problem and without any interruption, right? Sometimes those disks are local, sometimes are external with SAN system connected with network cards and fiber. So in those cases, even the connectivity between the server and the storage must be redundant, right, with a set of at least two network connection and two different cables. And many other components, right? Those many other components could be even the whole server, right? One day the server can crash and not being able to, start again, right? If that happens, we're going to lose our server and our SQL server in this case, right? We should be able to come up with something that as soon as possible, and we will go deeper on this as soon as possible in a minute, we can, recover and be operational right away. Now, and this is not only our server, it's also the networking, right? The network connection, the switches, we should have multiple connections to multiple different switches, and even the power source and the air conditioner, right? We should be able to identify that, if we have a problem with the power, of course, we're going to lose everything. Well, so we should have that covered also and considering it as a single point of failure. So when we build this, we have to identify, collect all this and be prepared, right? Then we're going to go through the techniques that we can use to have the business continuity at the top of this hardware solution that we will be covering. So at some point, we need to understand what HA is. And to do that, we need to be able to measure high availability, right? So we know that in a perfect, ideal world, we want to achieve 100% of operational time. That means that we never have a failure and no outage, right? So 100% of the time, so always, right? And continually operational. We know that this is kind of impossible, let's say. So we won't be able to reach this 100% time. So let's start seeing how we can measure all this. So the availability itself is the number of minutes in a particular month, and we have to rest the minute of downtime, right? So this time we will get, okay, if we have this amount of hours, minutes, seconds in a month, and we were down this amount of minutes, okay, our availability was this one, right? And why we know that it's not going to be 100% operational? Well, first of all, we know that we may have hardware-related problems, for example. But additionally, we also have to apply system patches, security patches to the operating system, to SQL, etc. So at some point, there's going to be even a minimum, but it's going to be an interruption when we apply all these updates, right? So we know that we may need to reboot our server at the end of the process or something. So for sure, we're going to have certain downtime, right? So knowing our availability through, for example, a given period of time, a week, a month, a year, is extremely important. Now, there are also other metrics that will be extremely useful. For example, the mean time between failures, MTBF, right? So that's, when we have a failure, we need to document all this. So we know how long it takes between one failure and the other one. And, eventually in the future, that may even be useful to maybe somehow predict when the next failure could happen, right? Of course, we know that it's not going to be linear, right? But knowing all this information is, okay, every month we are having a problem. Okay, so we need to do something, right? Knowing this information is extremely important. Then we have the mean downtime, right? What does it mean? For how long we have the system non-operational or down, right? Having documented this information is also important. And then something that we need to know and discuss internally with everyone in our IT system and also at the business level is their recovery time objective, bro. So that means if we are in trouble, how long do we have to come up online again? If it has to be a few seconds, or eventually it could be hours. We need to understand all this to especially create our environment at the beginning, right? Okay, so we said we won't be able to reach 100% of availability. That's going to be impossible. So how do we measure the availability? Well, this concept of service level agreement, or SLA, right? So if, for example, we are providing a service to our customers, when we sign the contract, we tell them, hey, we're going to have this availability in our system. So we have to sign that value and make sure that, of course, right? So when we talk about this, if we won't be reaching 100%, ideally we need to be as close as possible at this 100%. So we will try to measure the availability in nines, right? So 99.9, 99.999, and so on. So we said numbers of nines, right? So 3 nines, 4 nines, 5 nines, etc. And to have an idea of the amount of time that this represents, if let's say we have an SLA of 3 nines, meaning 99.9, we can be with our system not operational for 8 hours and almost 46 minutes, right? That seems a lot, but it's not. And if we, let's say, try to get additional SLA, for example, 4 nines, 99.9 is 52 minutes and a half per year. 5 nines is only 5 minutes and you see the last option is only 3 seconds, right? Of course, to being able to achieve these numbers of high availability, we definitely need to understand what it takes and definitely prepare our environment in that way. So how do we achieve the high availability, right? As we said, design the system having high availability in mind at the design level, at the very beginning, right? Once we have our system operational up and running, definitely we need to test the solution. I've seen a bunch of situations in where we believe that we were covered by HA, and when we had a problem, right? The system was not really prepared, and end result was downtime, right? So definitely we need to come up with periodical tests of the whole HA system just to make sure that everything works well when we need it for real, right? So it's extremely important, and also monitor the whole solution constantly, right? At hardware level, software level, networking, everything. It's important to understand, know exactly what we're doing. As I said at the beginning, know all the possible single point of failures and document all the information that we can get from this incident. And when we're testing the HA solution, I always say that these are one of the exercises that we learn a lot every time that we run one of these, because we, after completing one of these exercises, we know that maybe we need to adjust something to make it even better for be prepared for the real estate. So this is having high availability in our design. So if we go to a step further, right, we're going to start talking about disaster recovery. For high availability, I mentioned that we can have a problem in a disk, in our server, in the power source, etc. But what about if we are hit by a natural disaster, or the whole city lose the power source, right? Of course, doesn't matter how many servers we have in a standby mode, how many switches and how many disks our server has, we're gonna be affected. So we have to make sure that even for a natural disaster, we can be prepared to have business continuity. And in order to do that, we have to implement a disaster recovery solution. What is a disaster recovery solution? Well, in the on-premise world, right, as I said before, we come up with everything redundant in a single location, but we're gonna need another location remotely, right? It could be on a different city, in a different state, or even in a different country, right? Interconnected in where, we can synchronize our data, and we're gonna go to those techniques in a minute, right? And eventually, if we're hit by one of these really big problems, and we need to fail over to this other location, right? We can be up and running quickly, right? So again, this is important, and this happens in my career. I've been through a couple of real cases, like earthquakes in Chile or New Zealand, in where we really need to use the disaster recovery environment. I always say that definitely when we design and we prepare the environment and we implement it, those are things that we never ever want to use it for real, just for tests, right? But it could happen. In fact, it happened, right? And we need to be prepared for that, right? So this is basically a remote location with another set of infrastructure, servers, connectivity, etc., that is in some sort of standby mode, synchronizing our data, and if eventually we need to rely on this, we can do it. Of course, when there is an application, I would say that most of the time it's not the SQL Server only, right? SQL Server and the user databases are part of the backend solution. There are other applications, web servers, middle tiers, clients, etc., etc., etc. All the solution must have HADR capabilities, right? Because if we can only, let's say, take care of the SQL Server and we say, hey, in 5 seconds we are up and running again, no matter what. But if the other components of our applications are not HADR capable, well, it's the same than nothing, right? So it's important to consider that. We go to some of the practices, and you see here in this slide that I'm talking for the very first time about backups, right? Backups could be or not, depending on how we define it, a HADR solution, right? And why is that? Well, we as DBAs, we know that one of the most important things that we always need to do beside HADR is take the backups, right? Store the backups, and also periodically test those backups, right? When this is something that is not targeted to HADR properly, this is something that we need to do no matter what, right? And there are several techniques to do the backup, like daily, full backups, differential backup, transaction log backup. And why I said it can be considered as a HADR solution, because if eventually we lose our server, we can go to those backups, prepare a new server, and restore all the databases over there. It's not going to be immediately, so it's going to take some time. So our SLA will definitely go most probably beyond the 99%, right? But if this is a possibility, but again, we definitely need to take the backups. One of the best practices for backup is not also store it on the same location that we take the backup. I've seen multiple cases in where we take the backups locally to the same server in where the user databases are. And when the server is unreachable or we lose a disk or something, we not only lose the SQL Server, we also lose the backups, right? So we also, as a best practice, need to store those backups in a remote location, because again, if we have a natural disaster that may impact on the whole building, etc., we're going to lose everything, right? And it's also important to periodically test those backups. I've also been seeing a bunch of cases in where we say, oh, don't worry, we have the backups if something goes wrong. And when we needed to go to those backups, those were useless because they have some problems or something. So definitely we need to have this as a practice. Then, talking about SQL Server itself, there are certain features that can be considered as HADR solution. One of them is SQL replication, right? Definitely SQL Server replication, the main purpose is not HADR, right? It's basically to distribute certain tables to multiple other SQL servers, right? And eventually have a bidirectional replication. But, eventually, if you consider that we need to put in another system the data that we are dealing with, we can consider SQL Server replication for this, right? And there are several pros and cons, right? One of the most important cons is, and we're going to talk this for the upcoming features as well, is that it will require a manual failover if something happens. What does it mean? If we have a problem in our source server, right, it's not, I mean, the switch of the services from the original or the primary server to the, let's say, a standby server will not happen automatically. There's going to need a DBA, someone who can take care of this process. So, and you know, there are certain rules that you have to follow when you set up SQL Server replication, because this is more target to table level than the whole system or even a database. Then back in SQL Server 2005, Microsoft came with this interesting approach of database mirroring that today is discontinued, and we're going to see what happened after. But it was really interesting because it provided with the possibility of having the primary server and one replica, right, in where we were constantly synchronizing one or more user databases, right, in some sort of mirror mode. So we know that whatever we were doing on the primary server, right, it was replicated to the other database. So if we do an insert, update, or delete of anything in a particular user database, that was replicated on the other end, right? The main benefit is that if something happened at the source, automatically we were able to fail over the services to the other environment. So quickly, right, we were able to be up and running. This SQL Server database mirroring was discontinued and replaced it by another feature, which is the one that we still use, which is high availability groups or always on. Right? Another feature is SQL Server log shipping. This is a feature that is coming from, you know, many SQL Server versions, right? In where, you know, based on the concept of backups and transaction log backups, we were able to have an operational set of SQL shop that behind the scene was taking care of doing the backups, shipping the backup files to a destination server, and then applying everything over there. It was quite hard to maintain. It also required a manual failover, but one of the most important pros of this solution, which is still valid now today, is that it doesn't require enterprise edition, right? Database mirroring and availability groups always on are required enterprise edition. There are certain flavors that allow us to do that, the same with standard edition, but you know, the whole thing for HADR is coming in enterprise edition. So SQL Server log shipping also, you know, we had the possibility of doing this to multiple servers. So in case we need to do that, it was also good. But again, today, the main, let's say, HADR feature that everybody's using is always on availability group. We're going to cover that in a second. Also, to achieve high availability, we have the possibility of creating SQL Server failover cluster, right? Using a shared storage. What is this? Well, first of all, we need at least 2 servers. One of them acting as active and the other one as passive, right? When we install SQL Server, there is an option to say install it in a shared storage failover cluster. So we have to do the setup in a different way. What is the benefit of this? That basically two servers are sharing the same storage, but only one have access to the storage at a time, right? So the active node has the SQL Server services and the disk, in where we have the SQL Server binaries, and our user databases, right? If something happened to the active node, let's say the server just crashed or something, there is a process that can be either automatic or manual that allow us to do the failover. What is the failover in this case? Just switching the role. The node that was active now become the new passive, while the passive one become the new active. So the new active get access to the disk, and we have the server services already installed, just waiting, right, to get the disk, and end result, we don't lose a single bit of data, because again, it's using the same physical disk, right, while we continue to operate without any problem. There are certain amount of seconds that requires to do this failover process, right? Not many, right? But in few seconds, let's say, we can be operational right away. So, you know, this is shared storage failover cluster, and we can switch from one to the other automatically or manually, right? This is good for multiple scenarios. First of all, you can say, hey, but we have two different servers. Our application may need to change the connection string. Well, that is not true, because when we install one of these SQL cluster, we have the possibility of creating a virtual SQL Server name and IP address, all right? And that's the one that we will be using on the connection string. So it doesn't matter which is the active node and which is the passive. At any time, we will always be connecting to the SQL Server cluster name, right? So we have to, don't worry about that. So it doesn't matter which is the active, we will be able to operate with no problem. This is also really interesting for the cases in where we need to either patch our Windows or SQL, or even to upgrade SQL Server to another version, right? If we have a single server and a standalone server, and we need to apply Windows patches, Windows SQL, or do an update, that's going to require an extensive amount of time, right? Because you know that when we apply those patches, it takes several minutes. And if we are not operational, as we said earlier, we reduce the SLA, right? The availability time. So how we can take advantage of this shared storage failover cluster here? Well, first of all, what we do is we go to the passive node and we do everything that we need to do, right? If, let's say, we need to apply Windows patches, if we need to apply the latest cumulative update for SQL, we can do it without interrupting the SQL Server service, because, you know, the active node, the other node, is the one that is serving at that moment. We can even reboot the passive node if we need it, right? If it is necessary for the updates. So when we are ready with the patching on the passive node, the only thing we need to do is initiate a failover. So all the services will be moved to the new active node, which is already patched, and, you know, with the higher CU or the latest patch, etc. And that's it. So in a matter of few seconds, again, we will be operational once again. And then, you know, when the old active node that now is passive, right, we can go there and apply the patches at any time, right? So again, this allows us to have high availability in our system, right? Clustering is a feature that is in Windows Server since Windows NT times, right? So, and as I said, it gives us the possibility to create the cluster, have these virtual names and IP address, and have shared storage, right? For example, here I'm showing that our cluster has 2 nodes, right? And then when we install SQL Server within the role, right, we see all the disk associated to the cluster. Then we see the server, the virtual name and IP address, and the SQL Server services over there, right? And then here we can see the storage. It is interesting because at the top of a shared storage failover cluster, right, we can put an availability group, right? We're going to go through the details on availability group in a minute, right? But, you know, we say that we can have a third virtual machine on a remote location, right? In where, you know, we are synchronizing our databases. And again, instead of connecting to the SQL Server cluster, the availability group gives us the possibility of creating an additional virtual IP name, virtual IP and virtual name, so our applications connect directly to there. So it doesn't matter at the end of the day which is the server that is acting as the primary, right? We're going to be always able to get connected. So what can we achieve with availability group? Availability group is definitely the feature for accomplish HRDR. We can have multiple nodes, right, in an availability group. In this case, each of the nodes will own their own storage, right? So we can have one server with a set of storage and, you know, multiple of them sharing the same availability group. The concept here is that only one of these servers will be the primary replica, meaning the read and write replica. So our workload, our read-write workload will go to that replica, right? And we can have many secondary replicas. These secondary replicas are being synchronized with the primary and you know, there are read-only replicas. So additionally to the concept of achieving high availability and disaster recovery, we can have the same data that we have in our primary replicated to several secondaries, and eventually we can do select to in our secondary replica, right? So let's say if we have a workload that is, you know, reports or data warehouse that we need to just read data, we don't need to go to our read-write replica. We can go to any of the secondary read-only replica, and with that we can also, you know, handle the reads and write in a more efficient way. And eventually, if we need to failover, a failover in this case is basically switch the role. The one that is primary will become secondary, and one of the other secondaries will become the new primary, right? Again, here we're going to have a concept of a listener for the availability group that will allow us to have the virtual name and a virtual IP address. So some of the details on availability groups is that we have 2 modes, right? Synchronous and asynchronous. Synchronous mode basically allow us to have the possibility of, you know, when we go to our primary replica and we initiate a transaction, right? And if we have another replica that is configured on synchronous mode, right? Our transaction will go to both replicas, will commit, and when it commit to all of the synchronous replica, we're gonna get the acknowledge back, right? So the connectivity between the replicas that are configured in synchronous mode should be high speed, right? Because again, we're going to be committing our transaction in multiple SQL Server instances. And why is that? Well, that is basically to make sure that we don't lose any data in case we need to move to one server to the other, right? So this is synchronous mode. There is another mode, asynchronous mode, that, you know, when we initiate the transaction on our primary, we just get the acknowledge from there and we continue. And then in background, there is a process that is synchronizing asynchronously to other replicas. For example, this is quite useful for DR purposes because we know that the network connectivity is not going to be super fast. So if we use synchronous mode, it's going to generate some performance problem. But, you know, we can combine also in the same availability group to have some replicas configured as synchronous while others are configured in asynchronous mode. Right? And then we have the process of doing the failover. Right? To do a failover, we can configure the failover process to be automatically, or we can do it manually. Right? Something to have in mind is that to be able to do automatic failover from one primary to one of the replica, that replica has to be configured in synchronous mode, right? Because, you know, if we're going to do a failover, we have to make sure that there's going to be no data loss, right? So if something happened to my primary, automatically it's going to fail over to another replica that is configured in asynchronous mode. And then we have, you know, the manual failover that, you know, eventually we can also failover to a replica that is configured to use asynchronous replication, right? We're going to get a warning message saying that it could be some data loss because, again, this is asynchronously, so there's going to be some transaction that we may lose, right? But in a case of a disaster situation, that's going to be, you know, more than enough. You know? And then, as I said before, for the client connectivity, we're going to have the listener created, which is no more than a virtual name and a virtual IP address that will be the entry point to all the databases in our availability group. Right? From SQL Server, we see that we can have multiple replicas, multiple databases, and a listener. Right? This is how we're going to see it from Management Studio. In Azure, right, for the virtual machines, we have an additional set of availability solutions. For example, initially there were the availability sets. So in the same, let's say, Azure Region, we have 3 fault domains. So we can create a virtual machine in the domain 1 and then another machine in domain 2, right? And Microsoft assures us that they won't be doing any maintenance or any work on more than one fault domain at the same time, right? So that is good because, you know, if we have all our virtual machines in the same availability set or fault domain, if something happens, it's going to affect all our virtual machines. But, you know, having it distributed in multiple fault domains assure that they won't be doing it at the same time. Then Microsoft came with this concept of availability zone, which provide us additional SLA, right? So within the same Azure region, there are 3 different availability zones. Zones are different buildings with separate power source and high-speed network connectivity between them, in where we have all the resources deployed. So if something happens, it's going to happen to, most probably, to only one availability zone at the time, right? So this is also important to have in mind. So then going through the different options, we went through availability group, failover, cluster instance, log shipping, backup, restore, and in Azure, there is another option called Azure Site Recovery, which allow us to take, let's say, a snapshot of the virtual machine in case something happened. This is not ideal for SQL Server VMs, but for other kind of workload, it could be an option, right? Well, here we have some more details. I just wanted to go through the last part of the presentation and a quick demo. In SQL Server, during Ignite last year, was presented SQL Server 2022. Now, in May, Microsoft made the first public preview of SQL Server 2022, right? One of the features that is targeted to high availability and disaster recovery is the possibility of combining SQL Server 2022 with managed instance. So we can create an availability group and synchronize our databases between SQL Server and managed instance, right? And eventually do a failover to the cloud if it is necessary. Let's go to a quick demo, which I have here recorded because I had a problem this morning with my Azure subscription. So I will drive through here. Here is Management Studio. We have two virtual machines, VM01, VM02, and my availability group called my HE2. We have one database called Test, which is part of the availability group. Right? We are now sitting on the secondary replica. We have the same view on the other virtual machine, but one is saying primary and the other one is secondary. We're going to create a brand new database. We will take a full backup to make it ready. Right? So we see now we have my new demo DB ready. And what we will do now is add it into the existing availability group. Right? So we go to the primary, we hit add database, right? We're going to come up with this wizard, and the wizard will pop up saying that, you know, the data we have already the test database part of the availability group, and my new demo DB meets all the prerequisites to be added to the availability group. So we just move on, we connect to the secondary. If there are more than one, it's going to use more than one. And here we have the different ways to provision the other replicas. We will use auto seeding, that basically SQL Server will take care of provisioning the database on the other replica, right? So now if we refresh Management Studio over there, we will see that now it's saying synchronize it as well. Now in the availability databases, we see my new database over there. And if we go to the secondary node, now we see all the databases there and the same view for my availability group, right? So we just added a brand new empty database to an existing availability group, right? So what's next? We will go to the primary, the read-write replica, and we will create a table. Then on the table, we're just gonna add some random data from the sysobjects database. We go to the secondary and we see that we have the same table because it's fully replicated with the same number of rows, right? So going back to the primary, I will be deleting some of these rows. And we are in the read-write primary, remember, in the replica. So we go there and we access our data. On the primary, on the secondary, if I try to delete, right, on my user database, right, what I will get is an ugly error message saying, I cannot do that because it's a read-only database. So doesn't matter if I am sysadmin or not, right? The database is configured read-only because it's part of the availability group, right? So let's say that we need to fail over from the virtual machine 1 to the virtual machine 2. We just go to the wizard, we initiate the failover process there. We just say, hey, I'm gonna move to the other node. It is configured as synchronous, so we have no problem here. We're going to connect to the other node, and then the wizard will take care of the rest. And we will see that now that the virtual machine 1 was the primary, now is the secondary, right? While on the other virtual machine that was secondary, now is primary, right? Now, in the new secondary, if I want to delete, I won't be able to do it. And with that, okay, with that, we just covered the basis of HADR, shared storage failover cluster, and availability group. If you want to keep learning about the Azure SQL fundamental, here is the a QR code for you to follow. Well, with that, we just finished the presentation. Thank you so much to the organization and to everybody to attend to this session today. Gianluca.
Thank you, Javier. And we have a question, last second question. I was wondering which strategy can be used for accidental disaster on data, like wrong delete, update, etc. I mean, on a very big database, it's very expensive to restore the entire database just to get back some records. Getting back in time, 10 minutes just to recover data would be very useful. For example, an always-on secondary node replicated with some minutes or hours lag or something like that.
It's interesting. It's a very good question, actually. And if you go to the feedback page for SQL Server, you will see that that is one of the most voted options, or more voted questions or requests, right? Being able to have a database which is X amount of minutes or hours in replication delay. So in case of, for example, someone that accidentally deletes something on the primary, we don't need to go and restore the database again and extract the record, but instead we can go to the replica. That is not possible today. So if you delete something on the primary, synchronously, it will be deleted on the synchronous replicas, and with few milliseconds of delay, it will be deleted from the asynchronous replica, right? So today it's not possible, and today what you have to do for accidental problems like this is do what you said, do the restore of your databases and extract the data that you lost, right? Unfortunately, hopefully in the short future, we may have something better. Something also to add quickly here, and this is a feature in SQL Server 2022. In all the times I mentioned that availability group is synchronizing the user databases, right? But what happened with your SQL Server logins, your SQL shops, etc.? If you have a SQL login created on the primary server, right? Today it's not moving it's not synchronizing on the replica, right? So you have to take care of that manually. If you change the password on a specific login on the primary, you also have to do the same on all the secondaries manually. Same for the SQL shops. If you have a SQL shop, you have to take care of moving them to the other replica. There are multiple solutions for third-party and community tools, like, for example, DBA tools that helps you with that, right? Now, in SQL Server 2022, there is an option that is called contain availability groups that will have the very first approach to not only replicate the user databases, but also replicate a subset of the master and the MSDB database. So If you create a login on the primary, you will have it available on the replicas. Same for the SQL shard. This is coming in 2022.
Okay, thank you. I see no other questions. So thank you again, Javier. It was a pleasure to have you again also this year, and see you soon.
Thank you, everybody. Enjoy the rest of the conference. Bye.
Thank you.